Let's do another one. Let's do design a calendar. You're implementing a program to use your calendar. We can add a new event if adding the event will not cause a double booking. A double booking happens when two events have some empty intersection, non-empty intersection. An event can represent a pair of start and end, and then represents a booking on half. That represents a booking on the half open. Two events have some. Okay. Okay. It's an example. So from 10 to 20, obviously there's nothing or a thing. Then 15 to 25, yes. Oh, it can't. Why? Oh, because it intersects. Okay, ordered set Python. Let me see, because I've, oops. So it can be booked because it cannot be booked because the time 15 is already booked by another event. Oh, okay. 20 to 30. Okay. So if there's no intersection, okay. How do I compare to so let's say 10, 20 is already in my right? Right. Let's say 10, 20 is already in here, right? And I want to add 15, 25. How can I do that? Well, I can do that by checking, okay. If check the start time, if maybe I go through all the start time. I compare the start time to every single end time, you know? Okay, I think I'll do that. Self.events. We'll keep it like a sorted list. Sorted. Yeah. And then self.events.add start time and then print self dot. Let's see. So we have 10, 20, 10, 50, 50 20. Okay. Yeah, I think this is good. I don't know, there might be some weird edge cases. Okay, first off, I need to, for every event, start end in self.events, right? If let's say we compare the start time. Basically, we want to say the start time is less is if start time is greater than if start time is greater than end time, then we can add it and it will fix itself. If we can't, yeah, and then return true and then return false. No? Okay. Okay. Oh, no. That makes sense. Because if there's nothing, okay, if not self.events, then yeah, that's the edge case. No? Okay. True, false, and then false again. Or equal to, yeah. Wrong answer. Okay, so we have here book. Okay, I think I have this algorithm wrong. Double happens when two events have some non-empty intersection. Some moment is common in both events. Yeah, makes sense. Okay. I need to figure out a better range deduction. Right. So like I have 10 and 20. Maybe some binary search. Is there a binary search? Okay. Maybe a binary search. Do I do binary search with basically I want the start time to be not in between anybody. So I basically need to make sure that I'm above the end time and I don't care about the rest, right? I think so, right? Because like, okay, if I compare the smallest and the biggest, so why is this an overlap? Because if I pick the smallest of the starting, or the largest here, and then the smallest of these two, that's gonna be 15 to 20. So there is a so that's 15, 20. So there is a overlap. Yeah, I see. I take the largest starting point, which is going to be 15. And then the smallest ending point, which is going to be 20. These are the values they share, essentially. Yep, basically. Well, now let's do this comparison. 20 and 30. Right, 20 and 30. Let's take the smallest of the starting point, or the largest, so we'll do 20. And then compare these two. The smallest one, which would be 20. So there is no overlap, right? let's do like a 40 to 80, right? So I try to do another one here. So I do the smallest or the largest here, which would be 40, and the smallest here. And there's no overlap because that's impossible. That's an impossible range. Yeah, I think that's a good algorithm. Self.events or bookings. And then for every start S and E in self.bookings, so if the largest start is max of start time and the current S, smallest end, which is min and end time with E. So if largest return false and then return true, and we'll add the start time, end time, self.bookings the append. Yeah. No. Okay, perfect. She should ask tomorrow.